Hello, today we're going to start section 8.3 in your book. It is on page 329. We're talking about quadratic functions, and now we're going to be looking at them in standard form. Remember, standard form is y equals, or f of x is equal to ax squared plus bx plus c. And when we say that, a, b, and c are all numbers that are in front of those variables. So what in this example, I'm showing you it's in the book because I don't want to do all the graphing. We have three different equations that have all been graphed. And the way we would graph these up till this point to do this is you would pick a value for x and you would plug it in, and what you would get out would be your y value. And so, for example, if we put in 0 here, we would get 0 plus 0 minus 3, which is negative 3. And so that's this point right here. And then you would graph other points and till you had your parabola. Again, if we're looking at things that we know, this number is negative, it's opening down. All of these are negative. Do you see how they're all opening down? That's just something you would look at right away. What we're now looking at is what is something that you notice with all of these graphs when you look at the equation. And they've put it in red for you right here. Here is minus 3, here is minus 1, and here is plus 1. And if you look, the point 0, 1, and 0, negative 1, and 0, negative 3, this negative 3, 1, negative 1, and 1 of the c value is where it crosses the y-axis. And so that is just something, all of this is just telling you that when you have something in the form y equals ax squared plus bx plus c, that c value, that number by itself, is where it's going to cross the y-axis. And that's just something that you need to remember, okay? The next thing we need to talk about when we have a quadratic written in standard form is how can we find the axis of symmetry? Again, this is just something that I'm going to tell you, and it's something that you need to remember. It's one of those things that you will forget. You will be reminded of it later, and then eventually the more you do it and the more you continue in math, it's just something that you remember. The axis of symmetry is at x is equal to the opposite of b over 2a. And the reason it's x equals is keep in mind, here is our, if this is our graph, the axis of symmetry is a vertical line. Always a vertical line, which means it has to be x equals something. So it would be the opposite of b over 2a. I'm going to go ahead and use a problem as an example. If I have 2x squared plus 4x plus 3. When I look at this, this is in standard form. I'm going to say y equals, or of course f of x equals. I know right here, because of the plus 3, that is where it's crossing the y-axis, so that would be right here at the point 0, 3. I just know it hits there someplace. The next thing I need to know is to find out the axis of symmetry, because that's going to tell me where my vertex is. That's where my turning point is. This is opening up because this is positive, so I know my graph is going to look like this, which again means the vertex is at this has a minimum, which means it has a lowest value it will hit, will never go below this point, and does not have a maximum. We talked about that before, whether equations open up or down. So these are all things that you need to think about. For the axis of symmetry, it is at x is equal to the opposite of b over 2a. Well, if you need to do this, if this helps you in the very beginning, you can just take this equation and say, okay, a equals 2, b equals 4, c equals 3, if that helps you. So now I'm saying the opposite of b. Well, that means a negative 4 all over 2 times a, and a is 2. I have negative 4 over 4, which is negative 1. That means and on this one I was just drawing before I gave my example, this means at x equals negative 1, right here, this is my axis of symmetry. That means my vertex is along here somewhere. That being said, the first number in my ordered pair is negative 1, and I need to find the y value so I know where my vertex is on this line. And so what do? I plug in -1 into this equation, and then I'll see what y is. So y is going to equal 2 times -1 squared, I'm just plugging it in, plus 4 times -1 plus 3. Oops, I'm getting off the page a little bit. Plus 3. Okay, I just plugged -1 into this equation to get my y value. I have -1 squared, which is 1, and 2 times 1 is 2, plus a -4 plus 3. And then I just add these up. So it looks like y is equal to 1. Okay, so that means my vertex is -1, 1. And I'm going to go ahead and plot that point right here. This is also my minimum value is going to be at -1. Now from this -1, 1. Now from here, I just need to, I know I have this point right here at the point 0, 3, and since this is the axis of symmetry, I also know that this point right here is on the graph, and I can go ahead and graph it. If I really, another great thing that I really should do is pick another point for x, plug it in, and get that value. For example, if I put in 1, what would I get? I would have y is equal to 2, 1, the second power, plus 4 times 1 plus 3. 2 plus 4 plus 3 equals 9. So at the point 1, 9 is a point. So I would go here up 1, and or over 1 up 9. I would count over 1, 2, 1, 2, and then I would be able to graph my graph like this. And so the reason we're doing this, and this should be curvy, not more like a V, the reason this is way easier than just saying I'm going to randomly pick points. Can you randomly pick points? Yes, but then you're like you come into trouble like, well, where is my vertex? And that vertex is really key because that's your turning point. That's from when you're going down and turning around and going up again, or the opposite of that. So that's how you graph. I'm going to go ahead and graph another one. I'm going to graph the equation f of x equal to x squared plus 2x plus 4. If you would like to go ahead and write down your a, b, and c, just so you know, a is equal to 1, b is equal to 2, and c is equal to 4. When I look at this, I tell myself, okay, it's going to open up because this number here is positive. In front of the a is positive. First thing I'm going to look at, I know c tells me where it crosses the y-axis. So 1, 2, 3, 4. I'm going to put that point in here. Now I need to know where my axis of symmetry is. That will in turn tell me where my vertex is, because the vertex is on that axis. It is the opposite of b over 2a. The opposite of b, I have -2 over 2 times 1, which is equal to -2 over 2, which is equal to -1. So again, this is my axis of symmetry at -1. And I'm not going to do it really dark, but I need to know that it's there. Now my vertex, I know the first number, the x value is -1. I need to find my y value, so I'm plugging -1 into this equation. So y is equal to -1 squared plus 2 times -1 plus 4. And then I just solve. 1 plus -2 plus 4 equals 3. So now I'm at the point -1, 3. I'm going to go ahead and graph that. That is my vertex. -1, 1, 2, 3. Since this is my axis of symmetry, I know that since this is 1 over, I just count here, and that's 1 over. And then I could draw it, but I think I need to plot another point. So I'm going to go ahead and put in 1. You want to pick the smaller numbers because it's a little bit easier to work with those numbers. So now I'm putting in 1 for x and seeing what my y value would be. Y equals 1 squared plus 2 times 1 plus 4. 1 plus 2 plus 4 equals 7. So I now have the point 1, 7. Here's 1, and I go 1, 2, 3, 4, 5, 6, 7. When I have this point, I know that since this is the axis of symmetry and I'm 2 away, I count 2 here, I know that this point is also -2 7 is also on the graph, and now I can graph it just like that. So it's not, this is way easier than just randomly picking, like I said before, randomly picking points for x and finding out what y is. We're now going to look at comparing some quadratic functions. One of them is going to be in the form of a table, and the other is in the equation. And what happens here, we have a fountain with this water is going like this, and this is going like this. They've entered the values in here, and they've entered this is just an equation right here. And so what it's telling you is that you should find comparing the vertex of both of them. If I'm looking at the table and I look at these values right here, I can see it's going up, it's going up, it's going up, and now it's going down. And so what this means is when it hits this point and it starts going down and it's symmetrical, meaning this is negative 6, negative 5, negative 4, negative 3, negative 2, all going by the same interval, that this right here has to be your vertex, which means that the height of the water is 10, if we're talking feet, 10 feet high at this point. And when we want to know what this one is, since it is in standard form, we are going to use the opposite of b over 2a. And so when we do that, we are putting in, and they put the opposite out front, which is the same. I just put it in front of the 2. It doesn't matter if it's out here or up on top. But it would be the opposite of 2, so they still have the opposite here of 2. The opposite of b, which is 2, over 2a, which is 2 times negative 1. And when they substitute that and they solve it, they get 1. And so that just means we then have to put in 1 into the original equation, and when we do that, you get 9. And that just means that the height of this fountain is 9 feet. So b reaches a greater height. And that's just how you're doing that. You have to remember, like at the highest point, that's the vertex of the parabola. That is the maximum value. I think in order to do the last section, I'm going to have to do another video.